grid-connected solar battery energy system is actually called a BESS. So the battery part and the inverter part of it is called a BESS, which is basically the batteries, and it's the inverter on the other side. The solar part of it is up on the roof. That's obviously your PV arrays that actually feed the system as well. So basically it's called a hybrid system, which basically means it's connected permanently to the grid and has the backup of the grid should it need the grid to charge or to do work as well. Most of the savings come off the roof. So basically your solar is what you're saving from Eskom. So that energy is basically then brought forward from the solar from the roof. The container is built into two sections. There's an AC section, which is the inverters. All the electrical, the AC, the alternating current stuff goes in one side of the container. On the other side, we've got the DC side. So that would be all the direct current. That would be your batteries. Most of the time it would be your solar as well, would come in that side. And your solar combiner boxes would sit that side. That's direct current. We'd have the fire suppression installed as well. We would fit in a container. This is a 40-foot container. In a 40-foot, you can get about 2 megawatt worth of batteries in. If you're going up to the 2 megawatt size, you would put your inverters in a separate container altogether.
What's unique about these batteries is that they're second life batteries. So that means that they come out of electric vehicles and we reuse them for static storage. So the weight of the battery sometimes in electric vehicles becomes too heavy for it to actually be efficient for what it is. Whereas when you put it into static storage, you get the usage out of the battery with the same cycle life. And it basically reduces the amount of recycling that the batteries require, especially with lithium. Lithium is a very rare resource and it's being mined. So if we can reuse it from batteries that are currently very good and can still have 6,000 cycles worth of life, that's very useful to us. So it reduces the carbon footprint of having to recycle the batteries, and it helps with the whole environmental impact of global warming as a whole.
So ROI on a system of this size is normally about 5 years. It all depends on the usage inside. So a system of this size, a medium system of this size is normally about 5 years. You can use a peak in peak shaving form, where basically what happens is, let's say you had a factory that didn't have a system like this busy running in it, and what would happen is, as you put on machines in that, you get peaks, and these peaks basically cause you to flare up. You'll be using 100 amp, the next minute you'll be using 300 amp, 400 amp, as you turn on machines in the factory, and then they would switch off and that peak would go away. So these peaks are what cause a peak demand charge, which is probably the most expensive part of your electricity account if you are paying peak demand charge. So there's a couple of different things that we do. So we can use a peak factor correction firstly, and this basically corrects things, capacitance in a system, and basically then will already improve the peak demand that you actually got, number one. Then you can also put a system in like this. It basically flattens out the grid altogether. So what it does is it keeps the grid at a constant flow, night and day. And what it does is it actually uses the inverters, the battery and the solar to actually take out the peak. So it'll basically negate that peak. The peak is actually driven by the inverters and driven by the solar and driven by the batteries. So at night what would happen is you'd use the batteries and the inverters, and they would basically negate the peaks at night if you've got night peak demand. And then during the day what would happen is the solar would charge the batteries again and also negate the peak demand, and also then feed the peak and break the peak. So that's how it would work, and then you'd basically flatten the peak as well like that.
What normally happens is the customer will come to us with a design request, and we'll put together a initial high-level proposal that considers the demand profile of that customer, considers his geographic location, considers all his power sources, considers his battery needs, his inverter needs, and put that all together in one package, and then get into a installer who will come and build the system for them. And normally the client will actually select an installer already, and we will come in and hold hands with the installer and help him get through the entire 6-month process of the design, from request, design, configuration, ordering, delivery, installing, commissioning, and then long-term operations.
So with REVOV, with our HV, we first start with the sales. So you will come to us and ask us what your requirements are, and our sales team and our engineers will do a sales pitch for you on how much we think you would need for your required system. Then what we'll do is, once that's been approved, we have quality assurance. So I, as an engineer, would take a battery system that we've received of batteries, and I will test them according to whatever inverter you'll be using, and then I'll make sure that it will meet the specs of your site. From there, it will move to a commissioning team. Once it's at the commissioning team, they'll come onto your site, they'll make sure everything's installed until basically the batteries have been cycled and run, and basically that they're up to the standard of what we deem acceptable as REVOV. And then we also have a technical support team later on if there's any issues with the battery. Maybe one cell doesn't want to cooperate as well as the others. We'll have a technical team that can assist with that as well.
So, as REVOV, we are obviously more concerned about the DC, the direct current side of the project, because we're supplying the batteries and we're supplying the technology on that. However, we do need to make sure that the entire project is successful. So we will come and assist the installer in making sure his civils and his installation is up to code, up to standard, up to corporate level safety requirements. So we do a lot of on-site walks with the installer, on-site designing. We have a long history in getting sites built, for example, telecom sites and big switch centers. And that's just the nature of the people that we have in REVOV, that we actually can assist in getting the design and the installation correct on the civils and the foundations and so forth.